We spent a bit of time earlier in the year looking at the linear function, which of course was straight lines and all our coordinate geometry. The quadratic function is another very important function we need to look at. So quadratic polynomial and the parabola, because of course the graph of the quadratic function is the parabola. So let's just define a few things here. The quadratic polynomial is ax squared plus bx plus c. A polynomial is just an algebraic expression. Whereas a quadratic function is when you make it equal to another pronumeral. Most commonly we would see y. So y equals ax squared plus bx plus c technically is the quadratic function. Then the third thing we could have is the quadratic equation. So instead of making it equal to a letter, we make it equal to a number. Usually we see 0, and then we can solve the particular equation. So that's the technical name for the three different things. Now, of course, a lot of what we're going to talk about applies to all three because they are the same thing, basically. It's just the function we're thinking of, a graph equation with something we solve, the polynomial, a piece of algebra. Coefficients, well, we know what they are. They're just the numbers in front of the pronumerals. C is still a coefficient, even though there's no x there, because technically you've got x to the power of 0. It's the coefficient of. Not an expression we use that much anymore. Indeterminate. The indeterminate is x. I suppose it's another way of calling it the independent variable. We got free choice. We could sub any value in for x. The roots, well, they're the solutions to the quadratic equation. Okay? As opposed to the zeros, which are the x-intercepts of the quadratic function. Now, of course, they are the same numbers, but technically we have roots of an equation and zeros of a function. Although you will see people use the wrong terminology for the different situations. So if they're asking for a question like this, find the roots of x squared minus 1 equals 0, all they're really saying is solve the equation. And so, of course, that's just plus or minus 1. Graphing the quadratic. So we know it's going to be a parabola. The important things to look at. So there's our general form, y equals ax squared plus bx plus c. A tells us about the concavity of the graph. So we could have a happy parabola. And of course we're always happy when we're positive. Okay. That's what we call concave up. And we could have our sad parabola. And we're sad when we're negative. So that's concave down. B by itself doesn't tell us a lot, so we'll skip B for now and we'll go to C. C is the y-intercept, as it is with any polynomial. The constant number is going to be the y-intercept because the y-intercept happens when x equals 0, so all the other terms disappear. The zeros or the roots, depending on whether you're talking about the function or the equation, they will be the x-intercepts, as I said before. Now, as I said, B by itself doesn't tell us a lot. But B, when we use it in minus B on 2A, tells us a lot. That's the axis of symmetry. And that's important because the vertex will always lie on the axis of symmetry. Now, you don't have to use minus B on 2A, because if you've already worked out the roots or the zeros, because the parabola is a symmetric graph, it must be the average, because it's going to be in the middle. So if you've already worked out the zeros, you don't have to waste time going minus B on 2A, just average the two zeros out. That's going to give you your axis of symmetry. The vertex then, once you know the x value, will sub in and get the y value. Now, it's also the minimum or maximum value of the function. So if they have a question which says, find the maximum value, you don't give the coordinates of the vertex. They're just asking, how high does it go? So you just give the y value. All right, let's do a simple one. Y equals x squared plus 8x plus 12. So A is 1, so I know it's a happy curve. It's concave up. C is 12. So all right, my y-intercept is 12. Let's plot that in. The zeros, we just solve our equation. Nicely factorizes. So negative 6 and negative 2. Let's plot those ones in. There they are. That's probably enough to draw the graph, except the vertex would be nice. But if we're just drawing a rough sketch, that's probably enough. But let's find our vertex. So axis of symmetry, I could use minus b on 2a, which turns out to be minus 4. But as I said, if we've already worked out the zeros, it's probably quicker to just average minus 2 and minus 6. And that is, of course, minus 4 as well. Now, I wouldn't normally draw the axis of symmetry in when I'm drawing a parabola. This is more for the illustration of the example. Okay, so let's work out the vertex. We now know the x value, sub it in to get the y value. Coincidence, it turns out to be also minus 4. So let's plot that point in, minus 4, minus 4. Okay, that's more than enough now to graph it. Whee! There we go. There's our parabola. I asked you to find this. I'm telling you what the roots are. What's the quadratic? So the solutions was 3 and 6 to the equation. There's the answer. Now, the quick way of doing it is to think about how you solve quadratics. If you solve quadratics, you'd say, hey, what multiplies together to give the last number? What adds to give the middle number? So there's the key to creating the quadratic. What multiplies together? Oh, 6 and 3 multiply to give 18. So there's your last number. Add them, you get 9. But notice I put negative 9 down. I don't put positive 9. Because when you factorise it, you would have x minus something. And you say, oh, therefore, say x minus 0. X minus 0, that's a dumb example. X minus 3. And you say, oh, the solution is 3. So the sign would change. You notice I've got an a out the front. Because technically, any multiple of that would also have roots. So a is just some real number. Now, where that helps is an equation like this, or when I've got roots. Because I could waste a lot of time expanding that out. I mean, a lot of people would go, okay, well, let's make it x minus 3 plus root 2 and times x minus 3 minus root 2, expand the whole thing out. But if I use this idea, because the solutions will always appear in conjugate pairs in quadratics, when I add them, the surds will always cancel out. And when I multiply them, I'm going to have difference of 2 squares. So I know the solution. Difference of 2 squares, 9 minus 2 is 7. Add them together, I get 6. So negative 6 for the middle term. A lot quicker. By the way, I forgot to mention, monic, that's why I didn't have to worry about the a out the front. I know the coefficient of x squared is 1. Okay, roots 2 and 8. Vertex is the point 5,3. So I know it's going to be in the form x squared. Now, multiply 8 and 2, I get 16. Add them together, I get 10, so I've got minus 10x. Could be any multiple. They've now given me extra information so I can work out what a is. So let's sub in 5,3, solve it, negative 1/3. So there's my equation. It's just negative 1/3 times the x squared minus the 10x plus the 16. Just a quick recap of our inequalities. So whilst that's a quadratic inequation, I can think of it with the graph. So if I use the function to solve it, and this is telling me when is the function above the x-axis. That's what that's basically saying. So I can factorise it, draw myself up a little picture. I don't really care about where the vertex is or what the y-intercept. All I really need for this is what the roots are and whether it's concave up or concave down, and that'll solve the problem for me. So minus 3 minus 2, it's a happy curve. So when am I above? And there, minus 3, minus 2. So x is less than minus 3, x is greater than minus 2. Alternatively, you don't actually need to draw the parabola. You could say, well, minus 3 and minus 2 are my 2 critical points, and I'll just test a value, see whether I'm in between, because remember, solutions for a quadratic will always be either in between the 2 points or on the outside of the 2 points. So one last one. Let's make that look like something we can work with. So x squared plus 3x minus 4 is less than or equal to 0. So the roots of this one are minus 4 and positive 1. They're included in this case because it's less than or equal to. Happy curve. So I'm in between in this case. Alrighty, 8a. There's a quick recap on quadratics.